Hi, I'm Dr. Tim Komar, and today we will show a couple examples of integration by parts. First of all, the integration by parts rule over here. So if f and g are differentiable functions, then the integral of f times the derivative of g is equal to the product of f times g minus the integral of g times the derivative of f. Frequently, we use the following simpler notation. We just call u the function f, and we call v the function g. The corresponding differentials are du is just f prime dx, and dv is just the g prime of x dx. And substituting these expressions in terms of u and v into the equation we had on the previous slide, we're just going to get that the integral of u dv is equal to u times v minus the integral of v du. So integration by parts is used to write a difficult integral in terms of a simpler integral. So to use integration by parts, the goal is to identify the u and the dv so that the derivative of u is simpler than u itself, and the integral of dv here is going to be simpler than dv itself. If chosen properly, the resulting integral of v du will be easier to compute than the original integral that we started with, the integral of u dv. So the question is, how do we go about doing this? So we need to be able to choose that function u wisely. And there is a nice mnemonic for prioritizing how to choose u. And many textbook authors refer to this as Liate. And here, what the first letters stand for: logarithmic functions, inverse trigonometric functions, algebraic functions, trigonometric functions, and exponential functions. To use the mnemonic, we choose u to be the factor of the integrand that is of the type of function that appears first in this list. And again, this is a rule of thumb. Occasionally, you can do things in different orders and things can still work out. Particularly, some authors will interchange the priorities of exponential and trig over here. So here's the first example we're going to compute, the indefinite integral of x times cosine of x. So here, x is an algebraic function, cosine is a trigonometric function, and algebraic is higher on the priority list. So u is going to be x, and dv is going to be cosine x dx here. Then we're going to get that du is just going to be dx, and v is going to be sine of x. Then we're going to use the integration by parts formula, where we have u times v, x times sine x, and then minus v du. And again, remember that du is just 1 times dx over here, so that's why we just see the sign showing up here in the integral over here. And the antiderivative of minus sine is just cosine. And here we go, the constant of integration. That's it. It's not that bad. Here's another example that we're going to use with integration by parts. We're going to compute the indefinite integral of the arctangent function here. But notice this arctangent function just looks like a single function here. We don't see two different factors. Well, one can be considered a factor here. So here, since arctangent is an inverse trigonometric function and 1 is an algebraic function, we're going to let u be arctangent of x, and we're going to let dv simply be dx over here. So now du is going to be the derivative of arctangent times dx, 1 over 1 plus x squared dx, and v here is simply going to be x. Now we're going to use the integration by parts formula one more time over here. And here again, we have u, which is arctangent, v, which is the x, minus the integral of v du. So the v is the x, and the dx over the 1 plus x squared is the du. And this last integral here, again, is a little bit simpler than the original one here. We can compute this with a simple substitution where we substitute for 1 plus x squared over here. And this is going to turn out to be 1/2 times the logarithm of 1 plus x squared. And I did not put the absolute value signs around the expression inside the logarithm here because 1 plus x squared is positive. And again, plus a constant of integration. There are our two examples. And again, I'm Tim Komar. I am available for math tutoring for all high school and college mathematics courses, and I hope to see you. Take care.